everybody, welcome to an introduction to number bonds to 10, to 20 and multiples of 10 to 100. Okay, so our first factor is we are adding two numbers to make our magic number 10. So often you can do this either with equipment. So for example, I might say to the children, get a stack of 10, check you have 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Break it somewhere. What two number stacks have you got? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I can record my first calculation. 5 add 5 equals 10. I then might say to them, okay, put it back together, snap it in a different place. How many here? 1, 2, 3. 3 add 1, 2, 3, 4, 5, 6, 7. I can then record it down here. We also, of course, have our rather useful fingers. So this time I might say to them, okay, so here's your 10. 10 is what you need. Put down a certain number of fingers. So at this point, I might put down 7. 7 add how many fingers up? Now, some children will just literally bounce them. Some children will need to physically tap them on their nose, which is always quite entertaining. Okay, so I've got 7. How many more? 7 add 1, 2, 3. So here I have 7 add 3. I get the children to work through systematically. So if I said to them, right, put 10 fingers up, okay, I'm going to start with 0. How many more fingers do I need to put up to get to 10? Now start with 1 finger. How many more fingers do I need to put up? So either you could do 1 finger up, how many more to go up, or you could do put 1 finger down, how many are left up. So either way, whichever way your child prefers. So hopefully they should start to see that when they work systematically starting from the smallest number, so 0 add what, 1 add something, 2 add something, they get to the point where they notice that some of these number calculations repeat, but in a different order. So here we might have 6 add 4 equals 10 is the same as 4 add 6 equals 10. So they start to realise that with addition we can do it in either order. Addition, it doesn't matter, whereas subtraction, it does. Okay, so they can then start to say, well, what do you notice? How many possible ways is there to make 10? So there's also lots of like YouTube videos and online games and songs. There's one like with Row, Row, Row Your Boat, quite simple tunes that help them to work out their number bonds to 10. We can also represent our number bonds to 10 in a bar model. So for example, when we have number knowledge, our largest number goes to the top. So I know that 5 add 5 will give me 10. I know that here we had 10 at the top. I know that 1 add 9. So I've represented the 1 as the smaller part of the block. Okay, and 9. We can also use it for missing number problems. So for example, you might give it to your child, here's 10. I'm going to give the smaller block is a 3. So I know that 10, take away the 3 will give me this number, and 3 add something will give me 10. I can use my fingers, so here I have my 10. I'm going to put 3 down. How many left? 1, 2, 3, 4, 5, 6, 7. Here is my missing number 7. Now, we can also do this with a number line. So, for example, I can look at the fact that if I wanted to find a number, I wanted to say, here I've got the number 8. 8 add something will give me 10. So I circle the two numbers that I know I've got. I've got the 8 and I've got the 10. I'm doing addition, so I know I'm going to the right. How many bunny hops? Now again, common misconceptions is that they either do too many bunny hops, or that the bunny hops aren't landing exactly on each number, or that they do bunny hops or say their numbers faster or slower than they're actually drawing. So practice common misconceptions. So here is my 8, here is my 10. I'm going to count how many more bunny hops, add 1, add 2. Really good for missing number problems as well. It's also more challenging when you give them a calculation. So for example, where you start with the number that's missing. So here, something add 9 equals 10. So now they might have to use their inverse knowledge and go, right, well, if I had 10 and I had my number 9 knowledge, so 10, I'll have to use my inverse when they're a lot more confident. 10, do the inverse operation, 10 take away 9 will give me my missing number. Now, when they're confident using their number knowledge to 10, we can start to apply this to our number bonds to 20. So for example, here. Now, obviously, they don't have 20 fingers. You could go back and use 20 cubes, snap them in part. You could use your number line. So for example, if I wanted to do 16 add something is going to give me 20. I circle the numbers I've got. Here's my 16. Here's my 20. How many bunny hops? Careful counting. Add 1, add 2, add 3, add 4. Here's my missing number problem. Now the children can start to see that number bonds to 10 will have a link with large number addition calculations to 20. So here, I knew that 6 add 4 equals 10. There's a link here. I know that 3 add 7 is 10, and I could work out by using my number line that 13 add 7 equals 20. Now this is a really good opportunity to say to the children, well, what do you notice? Is there any common patterns between these calculations? They both end in a 0. This is 10 more. This number's the same. This number's the same, but I've added 10. This is a really good way of increasing the vocabulary and seeing that there are number patterns. That means they could use their number bonds to 10 to help them with their number bonds to 20. Now, we can also use our number bonds to 10 to help us with our multiples of 10 totaling 100. So, for example, here I have the fact that I might have my 100 square. Here's the end of my 100 square. Here's my multiples of 10 column. So 100, 90, 80, 70, 60, 50, for example. And I might say to the children, right, I want to know, here I know that 8 add 2 equals 10. I want to find out 80 add something equals 100. So they should know by now, and there is another video on how to use a 100 square, that when I go down a square, I'm adding 10. So I go add 10, add 20. Now I'd get them to do this quite a few times. So here we go, 7 add 3 equals 10. 70 add something equals 100. Let's do my counting. Add 10, add 20, add 30. Right, children, what do you notice? Well, they might notice there's an extra 0, so I'd add on, we timesed it by 10. Here we go, the 3's are the same, the 7's are the same, but now there's extra zeros. And you can talk to them about the fact that you're just timesing it by 10. You're increasing the numbers, but they can see there is a number pattern. So eventually you should be able to go, 1 add 9 equals 10, so 10 add what equals 100. By then they should start to see the patterns and understand that they're increasing it by timesing it by 10. Now, you can use your number bonds to 10, to 20 and to 100 to increase familiarity and confidence by using factor families. So, for example, I might know that 1 add 9 equals 10. I know that if I, as my children call it, flip-flop it, that addition can be done in any order. 9 add 1 equals 10. But there are 2 more calculations. If I was to do the inverse and use subtraction, it is important that children ultimately know their number bonds addition to 10 as well as their subtraction. So now if I'm doing the inverse, I'm going to start with the answer. 10 take away, I must use only the numbers that were included in the first addition. 10 take away 1 equals what number's left? 9. I'm going to flip-flop them, reverse them. So now 10 take away 9 equals 1. Same can be said for number bonds to 20. They should know addition and subtraction. And we can use this number knowledge, as we said, to help us with our number bonds to 100. So here I could go 10 add 90 equals 100. I know that addition can be done in any order, so that 90 add 10. I can then look at my subtraction, my inverse operation. 100 take away, 100 take away. Pick one of the numbers that was there. What number was left? Well, I've done the 100, I've done the 90, so it must leave the 10. Reverse these numbers this time. And I can use my number knowledge of number bonds to 10 to help me deal with some much bigger numbers and also learning factor families. Because importance is understanding that maths is all connected. Addition and subtraction are inverse. You can reverse the addition to actually in either order and use simple number knowledge, small number facts to help you with much bigger calculations. Hope that helped.